So now we get to talk a little bit about the protractor postulate. And the protractor postulate has a lot of analogs to the ruler postulate. So you'll see a lot of similarities here. All right. So we're going to start by saying we can arrange things in a specific way. Okay. Let's see what that looks like. The set of rays from A to X lying on one side of line AB, including ray AB, can be assigned all the real numbers x such that x is greater than or equal to 0, as well as less than or equal to 180. And we're going to call those values coordinates. All right, so here we have line AB. And what that's saying is I can think about all the different rays. They go through some point x. Okay, and so we're going to call this x1 and x2, and we're just going to put x3 or all these x's anywhere on one side of the line. Okay, because now I can draw rays that go through all of these points. Let's put some points up there too. Okay, so now I can draw rays that go through those points. All right, but there's an infinite number of those rays. All right. And those rays, okay, so you see all my rays now? Now those rays can be assigned values between 0 and 180, okay? So we're gonna say all of those rays, every single ray that could be drawn, could be assigned to a coordinate that's somewhere between 0, including 0, and 180, including 180. And actually, for this purpose, we're gonna say 0 to 180, all right? We can make these assignments so that these four conditions hold, okay? We can say that each ray is assigned to a unique coordinate, okay? That means that each ray is going to go through one value, one and only one. Let's say x1 goes through 70.2, okay? Then it's only going to go through 70.2, nothing else, okay? So that's the first condition. The second condition is no two rays are assigned to the same coordinate. AX2 going through 70.2, not another ray, even though I can draw an infinite number of them, will go through 70.2. The third condition is the coordinate of ray AB is 0. All right, so that means that this coordinate is going to be 0. All right, so I can make it so. Does that remind you of Star Trek? And then the last thing is if rays AC and AD have coordinates C and D, so some values C and D. So in other words, like what do we say, 70.2, and let's just say that this is 55.2 to make it easy, all right? 70.2 and 55.2. Then the measure of angle DAC is just going to be the difference of those two values with absolute value bars around it. And that's just to preserve the positive nature of that measurement. We talk about these angles as positive values when we're dealing with the protractor like this, okay? So we could say, what if we said this was 70.2 and this is 55.2, that this angle right here then would be what, 15 degrees then? All right, so that in essence is what the protractor postulate says, and we use this a bunch. We don't really use all the tenets of it, but they're implied in what we do. Whenever you lay a protractor down to measure an angle, and you know that you've got one ray going through 30 degrees and another ray going through 70 degrees, and that angle measure, you can subtract the two and you would end up with 40 degrees. right? So that is really applying the protractor postulate. Well, we might not always say, by the protractor postulate, the measure of this angle is, that's exactly what we're doing. Okay, in the next video, we're going to move on into triangles, and I can't wait to talk to you about them.